Okay students, so we are starting alternating current. Okay, alternating current. So the alternating current and alternating voltage. Okay, we know about DC, direct current. All the currents which we have discussed in current electricity is what? DC. So if we plot DC, okay, with respect to time, the value of current or voltage, it will be like this, no? Okay, we say no, 2 ampere or 2 volt. So graphically this is how it is going to appear. When we take AC, the typical AC signal which we are going to deal is sinusoidal signal. Okay, sine wave or cosine wave. So it will have this appearance. Okay, so this is sine wave. Sine wave, either current or voltage. Okay, sine wave. So sinusoidal signal. Okay, same way sine wave. Okay, same way we have cosine waves also. Cos. So cos means it will start from here like this. So this is also what? Sinusoidal signals we can say. Cos wave and sine wave. So whatever mathematics we require, I will be mentioning that parallelly. So you need not think about, you do not know mathematics. Doctors need not know that much, right? So that's enough. So sinusoidal wave, cosine waves. These two are the general signals which we are going to deal. Okay. Now suppose draw a wave like this. Okay, what about this? Is it an AC? AC or not? Interact. You can say yes or no. Mistakes, no worries. Okay, when you interact panlena, what will happen? You will start sleeping. Then I will also start sleeping. Okay, so whether this is an AC or not? How many of you say AC? Raise your hands. How many of you say not AC? I don't have any worries. This is also AC. This is also AC. Okay. So any wave which changes its direction, any wave which changes its direction without changing the amplitude, without changing the amplitude are AC. Amplitude means what? This is what is amplitude. Okay, suppose if I write this is current I is equal to I naught sine omega t, then this I naught, that is what is this. Okay, we will discuss this in detail. This is what the maximum. So this is the amplitude. So amplitude, this one same. Here this is amplitude, same, minus I naught. Okay, so amplitude must be same. It should not change. Okay, suppose if I see like this. Would this be AC? Changing the direction, that is good, but it is not able to maintain the same amplitude. Okay, so this is not AC. Clear? Okay, so those who do not know, you should understand that the maximum value of the signal is called amplitude. The maximum value of the signal is called amplitude. This is also called peak value. Okay, amplitude or peak value or all these are same. if I draw a signal like this, okay, so this is also what? AC. Sawtooth waveform is also AC. Okay, clear? Okay, now what about this? AC? How many of you say this is AC? Just raise your hands. Number of family within us. No need to just have any hesitation. Romba manam, maryada, no need to think like that. Just raise your hands, those who are saying this is AC. Okay, those who are saying not AC. Okay, so this is not AC. Thing is, direction is not changing. Direction is not changing means value of current is increasing and decreasing. Suppose I say this is 3 ampere, 2 ampere, this is 0 ampere. Positive current only. Value of current is increasing, decreasing. Direction is not changing. When we put something in the negative direction, this is what? If current is flowing like this, the reverse direction. So this is negative. Here everything is positive. Okay, so that is not AC. Okay, so direction change requires this also. Clear? Okay. Now we will discuss about a signal I is equal to I naught sin omega t. How this came? In electromagnetic induction we have studied E is equal to minus d phi by dt. And what about this phi? What is phi? B A cos theta. B dot A. Remember, no? Till electromagnetic induction you have completed, no? Small doubts also if you have, ask now. Once if you settle all the doubts in the beginning stage itself, then later you will not have those doubts. If you keep doubts with you, everywhere this will trouble you. Okay, so any basics, any problem, dot product, cross product, direction, anything, okay, please address it now. Can I write theta is equal to omega t? Is it okay? Can I write theta is equal to omega t? Theta means angular displacement, omega is what? Angular velocity. This is just like what? S is equal to V into T. Okay, one is a straight line, another is rotational. That's it. That is the only difference. Okay. So if we write phi is equal to BA cos omega t. Okay. Now if we write E is equal to visible, right? Okay, E is equal to minus d by dt of BA cos omega t. Okay. Now among them, which are all constant, which is variable? Magnetic field we cannot, for solving problems we can change magnetic field. Okay, for problem's sake we can change magnetic field. But here big magnet is here another big magnet is there. We don't have, unfortunately, no Avengers, right? Thor, Thanos and all, not in the real world. So they cannot change this magnet. Correct? We cannot. So this is constant. B is constant. Area, if this is a coil, if it is rotating, area cannot be increased and decreased. Okay, that coil will have to be constant. So A is constant. Then d by dt of cos omega t when we do. Okay, so minus is here. So what will happen? E is equal to minus BA omega minus sin omega t. Correct or what? Okay, so if number of turns are there in this coil, In this coil, one area is there, one turn. One coil means one area. One more coil, two area. Three more coil, three area. N number of coils means n area, right? So what also will come? N turns. Okay, E is equal to NBA omega sin omega t. So here maximum value of sin theta will come is 1. Maximum value of sin theta is 1. Okay, so this is nothing but the maximum value of EMF. So we can say or EM or E peak. So when we write this E, okay, that okay, this value E by R will be obviously maximum value of current. So I is equal to I naught sin omega t. Okay, so இவர் வந்து உருவானது இப்படிதான், அதோட கதை. Clear or what? Right. If I am about to erase, if you want me to stop, then just indicate that. Okay. Why all these discussions are done? Why? Because some students may not be very comfortable with the sin omega t. Omega பார்த்தாலே பிடிக்காதவங்களுக்கு டாட் வெக்டர் இது பார்த்தா நிறைய பேருக்கு பிடிக்கல, வந்துட்டான் போச்சு அவ்வளோதான். Okay, so those things should remove. So that how that will happen? Through continuous discussion. ரொம்ப டிஸ்கஸ் பண்ணும்போது அது மேலே ஒரு பிரியம் வரும். Shall I erase everything? Right, so E is equal to E naught sin omega t. I is equal to I naught sin omega t. When we draw this wave, this kind of appearance, or this can be omega t, or nothing wrong if we write in terms of t also, and this can be just if we write this as I. Okay, what about this omega? This is nothing but angular frequency. What is angular frequency? Angular frequency means how many times this is rotating. How many times this is rotating, or how many times this circle is happening in a second. Okay, if the time that stops here, if this is 1 second, we can say frequency is 1. Then we can say once this has taken, if we compare this with the circular motion, 1 cycle. So if 2 times, then omega is going to be what? Omega is equal to how many times 1 circle? If there is only 1 circle, then 2 pi into 1. Double. Then omega is going to be 2 pi into 2. 2 pi into 3. So for this, what we have taken, 2 pi f. How many times it is rotating? 1 second, oh, 10. Then f is 10. So this omega is nothing but 2f. That is the number of cycles in 1 second. So f is equal to frequency, then time period, that is time taken for one cycle, is nothing but the time period. Time for one rotation. Time for one rotation. So this omega is 2 pi f. This thing can be written like 2 pi by t also. 2 pi by t also. Clear? So in this signal, I naught is amplitude. Sine vanda kada ungalku purinjudhu. Omega is nothing but angular frequency, which is nothing but 2 pi f or 2 pi by t. Okay, so how many cycles per second, how many waves per second, that is frequency. Time taken for one cycle is what is time period. Clear? Okay, done. Next thing is phase. Phase is what we can say is, suppose if I consider like this, I is equal to I naught sine omega t plus phi. Sine omega t plus phi. When I say this is peak value or maximum value, what should I say for this one? இதுக்கு என்ன பேர் சொல்லி கூப்பிடலாம்? கரெக்ட் தான். இதுக்கு IRMS பரவாயில்ல, நோ ப்ராப்ளம். ஓகே, 100% ஃப்ரீடம். நீங்கள் அதெல்லாம் பயப்பட வேண்டாம். தப்பு சொல்கிறதெல்லாம் நோ ப்ராப்ளம் அட் ஆல். ஓகே, ஸ்டடி வெல், தட்ஸ் இட். நோ இஷ்யூஸ் லைக் தட். தப்பு சொல்கிறதுக்கு பயப்பட வேண்டாம். ஓகே, யூ எக்ஸ்பிரஸ் இட். அப்படி சொன்னீங்கன்னா தட் திங் இஸ் லைக் ஐ கேன் அண்டர்ஸ்டாண்ட், லைக் வாட் இஸ் யுவர் அண்டர்ஸ்டாண்டிங், தட் இஸ் இம்பார்ட்டன்ட். உங்கள் லெவலுக்கெல்லாம் நான் இல்லை. ஐ டீல் ஒன்லி half of or some part of the physics. You are dealing physics, chemistry, biology. நமக்குள்ள போட்டி வச்சுன்னு வச்சுக்கோங்க, நீத்தெல்லாம் நான் எழுதிச்சுன்னா அவ்வளோதான். Okay, so you are much superior. So just rock it. Okay, come on. Yeah, என்ன கேட்டுட்டு இருந்தேன்? இதுக்கு என்ன பேர் சொல்லலாம்? Instantaneous value. Why we call instant? Instant means what? Instant. புரியுதுங்களா? இப்போ என்னது? ஓகே, அந்த பையன் எப்படி? பரவாயில்ல சார், சுமாராக இருக்குது, மகளுக்கு பார்க்கலாம், சுமாராக இருக்குது, அதெல்லாம் வேண்டாம். இப்போ அவன் எப்படி? இப்போ காலையில் கொஞ்சம் பாரில் போயிட்டு இறங்கி வந்துட்டு இருந்தோம். ஸோ பையனை பற்றி எப்படின்னு கேட்கும்போது 1 year கேரக்டர் ஃபுல்லாக எடுக்கும்போது எப்படி ஆவரேஜ் கேரக்டர் எப்படி இருக்குது? இந்த 3 நாள் 5 நாளாக தான் தண்ணி அடியெல்லாம் ஸ்டார்ட் பண்ணியிருக்குது. அவர் வந்து முன்னாடி ரொம்ப நல்லா தான் இருந்தார். ஆவரேஜ் வேல்யூ எப்படி இருக்கும்? சூப்பராக இருக்குல்ல? அப்போ பையன் மாமனார் இந்த ஹூ இஸ் கோயிங் டு ப்ரொசீட் நோ, ஹி வில் பி ஆஸ்கிங், இப்போ எப்படி, இன்னைக்கு எப்படி, இப்போ எப்படி, நவ் வாட் இஸ் த ஸ்டேட்டஸ்? இப்போ கொஞ்சம் பாரில் இருக்க, என்ன பண்ணும்? அட்டி தான். கரெக்டு தானே? ஸோ வாட் இஸ் த current value at a particular instant? That is the meaning of this. Suppose just like a washing machine, throwing the dirty clothes, taking the white clothes, nice clothes, right? Same way, if I put here, say for example, omega is equal to 100. Suppose if I give a value just like 2 seconds, just for understanding. Okay, sine 200 value will be getting, some value will be getting, so value say roughly will be getting, right? So throw time t is equal to 1 second. Ooh, I got instantaneous value is 3 ampere. Time t is equal to 3. I am getting the value of current. So for a particular instant, what is the value of current I will be getting from this? This is only peak value. RMS kadeke we will come. This is peak value. This is instantaneous value. What the value of current at an instant? ഒരു നൊടിയിൽ അല്ലന time t is equal to 5 seconds or 9 o'clock 5 seconds likewise. Okay, instantaneous value. Clear? Now this part is called phase. This part is called phase. அதில் வந்து இந்த 5 குள்ள t இருக்குதா? T is there. If t is not there, then that is constant. T irundada it will change, correct? No, x irundalu enna agum, change will be there. If something is there, n pair enna, what is my name? sk thane, appadi thane pair pottu koduthirukkudu. Okay, if my name is sk is equal to f of x nu koduthinga edam maarudukku thanda mari I will also change. Okay, inga office room போகும்போது ஒரு character, கீழ வரும்போது இன்னொரு character, ஊருக்கு போகும்போது இன்னொரு character. Okay, புரியுதுங்களா? sk is equal to f of x, function of x. In the all distance தகுந்த மாதிரி he is changing variable. sk is equal to f of t. காலையில் ஒரு மாதிரி இருக்கும், மத்தியானம் ஒரு மாதிரி இருக்கும், நைட் ஆகும்போது character வேற. Correct or what? So function of time. So t இல்லைனா constant தான். So this is called initial phase. This is called initial phase. Okay, suppose initial phase. What is its physical meaning? I will tell. Omega t is instantaneous phase. Okay, instantaneous phase. Clear or what? Okay, clear? So phi is equal to initial phase, omega t into ipdi, omega t plus phi is equal to instantaneous phase. Okay, phi is equal to initial phase, omega t plus phi, putting together the entire thing is phase actually. This full is phase. Clear? So omega t plus phi is instantaneous phase. Okay, ipo Shabari nammaloda nanban Mukesh Balasubramaniam ellarume nama friends da. Balasubramaniam started at 9 o'clock. I started at 9:05. So he is ahead of me by 5 minutes. Timing tagunda mari sollumbodhu. Same way, suppose we have lead and lag. We say lead and lag nu solradhukku meaning enna na, suppose if I say E naught sin omega t, naught sin omega t plus phi, means it is just like into சும்மா t minus 5 minutes னு வச்சுக்கங்க. So Bala கிளம்பியதிலிருந்து I will be moving after 5 minutes. Clear or what? Simple. Namma example within us, the example that we can understand. Same way, if we sin omega t, I is equal to I naught sin omega t plus phi, means this I is leading voltage by phi. I is leading voltage by phi. Innum sonna I will கோவப்பட வேண்டாம், மெதுவா கோவம் வரும்போது அப்படியே சும்மா. Okay, within us. Okay, so means I will attain maximum value before E. The meaning of this is I will attain maximum value before E. This is how. Suppose if I do Yes. So E is equal to E naught sin omega t. This is nothing but E is equal to E naught sin omega t. But I is equal to I naught sin omega t means he is Z. So we can say that he will be reaching the maximum value before E. So from somewhere it might have started. So this here it is the maximum value. So if we draw like that, before becomes I is E. Okay. Coming like that. Okay, so this is what is the phase lead or phase lag. Clear or what? Okay, so phase lead and lag is this. So here I could say that phi. Okay, so I reaches maximum value before E. Clear? So suppose now let me ask you, okay, Bharat, you are Bharat, right? Your name is Uday. Jeron, correct? No, Jeron. Okay. Your name? Samarish doubt கேட்டதே இல்லைன்னு நினைக்கிறேன் குரூப்புக்குள்ள. இனி கேட்டால் தான் எனக்கு பேர் ஞாபகத்தில் வரும், கேட்போம். Okay, so here suppose when I ask like if the voltage leads current by pi by 2, voltage leads current by pi by 2 means what will happen? எப்படி இருக்கும்? Mathematically if I say voltage leads current by pi by 2 means which one is sine, which one is cos? Voltage leads current by pi by 2, then which will be sine omega t and which will be cos omega t? Voltage will be cos omega t. Okay, see okay, see this is sine wave. தெரியலனா இப்போ தெரிஞ்சு வச்சுக்கோங்க, just understand it now. What about cos wave? Cos wave will be like this, no? Cos wave was like this. இங்க cos 0 is equal to what? 1 தானே. So here it is 1. Sin 0 is what? 0 தானே. It is there. Correct or what? Same way everything you can. This is sin pi by 2 is 1. Here it is. Sin. So suppose if we say E leads current by pi by 2, it is nothing but E is equal to E naught sin omega t plus pi by 2. அப்படி எழுதலாம். Or otherwise what also we can write E is equal to E naught cos omega t அப்படியும் எழுதலாம். Correct or what? Suppose if we write I is equal to E naught omega t, we can stop there. Correct? So cos start, it is just like what? Cos started in the year 1985. Sin is starting in the year 1990. 5 years late likewise. Okay, so these are the fundamentals for understanding. അറിയാൻ പറ്റത്തില്ല സമയം പോകുന്നത്. 40 minutes ആകുമ്പോൾ കൈ നോക്കണം എപ്പോഴാണ് നിർത്തേണ്ടത്. 45 നിർത്തണമെന്നല്ല പറഞ്ഞത്, 1 hour. ഇപ്പോൾ സമയം എത്രയും 30, 1 hour നിർത്താം. Okay, done. Clear? Audible? Right. So now we have heard about RMS velocity. So why should we study that? Why should we study RMS velocity? When you speak out, you can remove this and say the answer. Other times cover it. Okay. So why should we study RMS? Syllabus il potirukudanaaleyo. ആണോ? ഓക്കെ. എന്തിനാ ആവറേജ് ഒക്കെ എടുക്കുന്നത്? അതൊക്കെ എടുത്തിട്ട് RMS എടുത്തിട്ട് നമുക്ക് എന്താ ഉപയോഗം? അത് കിടച്ചിട്ട് കറക്റ്റ് ഇതാ വാട്ട് യു ആർ സേയിങ് ഈസ് കറക്റ്റ്. ഓക്കെ, അത് കിടച്ചിട്ട് എന്നത് measure பண்ணலாம். You came very much near. Yes. So thing is like AC is just like this, no? எப்போவுமே மாறிட்டே இருக்கும். கரெக்ட் ஆர் வாட்? ஸோ இந்த மாதிரி கேரக்டர் இருக்கும்போது very strong treatment we will have to do. So to measure AC, the technique which we are using is heating effect. Heating effect. So what is energy in DC? What is the formula for energy in DC? I base பண்ணும்போது I and R. I square RT. I square RT. So அங்க என்ன இருக்குது? I square RT இருக்குது. So that is in DC. Same value of on the I square இருக்குல்ல, that we will get in AC if we calculate RMS velocity, RMS current or RMS voltage. அங்க என்ன இருக்குதோ, suppose say for example we send a DC current, பார்த்தா we got 5 joule of heat. So when you throw AC, 5 joule of heat deliver பண்ணும்போது how much current should be there? If we calculate, because as you all said, this is varying. Your name? Stevak. This is Cedric and Stevak. Okay. So as you said, since this is varying, we cannot say a specific current value. Correct? No, it changes with the time. So but if we are able to calculate that RMS velocity, same heating effect, just like a DC gave, same effect we will be getting here. Okay, that is why we are studying RMS value. One thing. Another thing is we use voltmeter and ammeter for measuring current and voltage in DC. So here we will be using, if we keep hot voltmeter and ammeter in AC, it will show 0. Because average value is 0. Average value, how it comes 0, that we'll see soon. This is going to be showing 0. Measure பண்ண முடியாது. So in order to measure this, we have used the heating effect. How much heat it is giving, based on that we will be giving measurement. How much, so you see AC has passed, how much heat is delivered in that resistor or a heating filament, அப்படின்னு பார்த்துட்டு then what we will do, accordingly how much current is possible if it is DC. புரியுதுங்களா? Once again I will repeat, how much heat is delivered, say for example 5 joule. So I square RT if we do, how much is that current? if we see that, we will be able to show some measurement. That is what is RMS value. So I square RT in DC is I square RT. I square RT in AC is I RMS square RT. So how much is the voltage in your home? 220. What is that value? 220 is peak value or instantaneous or RMS? RMS value. Kandipa we could say instantaneous chance illa. Eppadi solla mudiyum? 220 vary aayirukkulla. It could have been peak value. Okay, so it is not peak value, it is RMS value. So please understand this. Any question anywhere, if AC is the source, if they are saying 220 volt or 200 volt or 100 volt or 2 ampere, 1 ampere, take it for granted that that will be RMS value. RMS value. Okay, so heating effect we are making use of in order to measure current as well as voltage in hot wire ammeter and hot wire voltmeter. So the measurement devices, okay, so the measurement devices which we are using for measuring AC is hot wire ammeter and hot wire voltmeter. Hot wire ammeter and hot wire voltmeter uses heating, okay, heating effect for measuring current and voltage. Okay, so that current is nothing but IRMS, respective voltage is VRMS. Okay, done.
Hot wire ammeter and
Hot wire. Hot wire ammeter means this is its name. Hot wire ammeter and hot wire voltmeter is its name. It is nothing but how much heat is delivered in that filament. So based on that heat, calibration will be done and voltage and currents will be shown. That is the concept. Just like a moving coil galvanometer will be calibrated, no, and it will be showing based on the deflection of the needle. Okay, this will be rotating using the concept of torque. So this will be moving. There we would have written the required values. That is what is calibration. So inge and the heating effect will be used. Clear? Now this average value, what is average value? Average value of AC is same as the DC value. Average value of AC is equivalent to the equivalent DC value. If it was DC, how much is the current? That is same as the average value in AC. Okay, please understand that. Now suppose if I take I is equal to I naught sin omega t. Okay, of this. So any function, if we need to find the average, what we do? 0 to t f of t dt divide 0 to t, okay, dt. Anything, if we any function of time, if we need to find average, this is its mathematical formula. Okay, indicate to for how much time we need to find average, because this is a function of time, Leah. This is a function of time. Based on time, this is going to vary. So if we ask, I need the average value, then a question will come, till what time? Because it is time dependent, it will vary. So you want average value from morning to evening or morning to noon. So for how much time we need to find the average, that limit we will have to put here. Function dt, divide by number of whole marks, divide by number of subjects. So time duration of that function divide by total time. So that is what 0 to t, like, so this is nothing but actually integral 0 to t f of t dt divided by how much time. That I have written for understanding like this. This is what, this process is important because there are questions. Through this only we will be able to find RMS value. Okay, suppose you will be getting some questions like 3 plus 4 cos omega t I is equal to something like that can come. We need to find the RMS value of this thing. Okay, suppose if we RMS value means peak value divided by root 2. If you think like that, then taken these two 7 by root 2 and all, if you try to write, that option also will be there. Okay, நமக்கு அதெல்லாம் பண்ணும்போது we will get mental peace மட்டும் தான் இருக்கும், மார்க் இருக்காது. Okay, so this basics we will study. Okay, easy, everything is easy. Okay, physics is the easiest subject, no? All of you already know, right? So average value of this thing, if we try to find for full cycle, we will take. For full cycle means full time period, 0 to t. Okay, so what I'm going to do is 0 to t I naught sine omega t dt divide by full time period. This t I have put there. Okay, now just integrate this. I naught, what is integration of cos omega t? Integration of sin omega t minus cos omega t. So minus cos omega t, then by omega, and this t is also there. This is what, right? 0 to t. Is it correct? Correct or what? Okay, so when we do this, what we are getting? Omega, we will take it out. This is cos omega t minus cos 0. This is what we get, right? Okay, so what is the answer of this? Omega is what? 2 pi by t. Correct or what? So what is the answer? See, minus I naught, this is t divided by t into omega. This is going to be cos, see, 2 pi by t. This omega is 2 pi by t into t if you do toto. Okay, so this is going to be cos 2 pi minus cos 0. What is cos 2 pi? This is minus 1. Just see. Zero. Pi by 2. Pi. 3 pi by 2. What is this? 2 pi. If you have doubt, draw the figure and see. Enge matakudadu. Basics should be strong. So minus pi, minus 1 now. Just draw the figure and see. Clear? So what is this? 1. So this is 0. So you all said before, average value will be 0. That is why we are going for RMS now. So this is why we are getting 0. Clear? Now what we will do now, for full cycle, this is the problem. For full cycle, if we are trying to find average value, we are getting 0. Okay, so one thing is pakka. Okay, put this in your mind. Average value of sine and cos for full cycle, it is going to be 0. Pakka? Clear? Average value of sine and cos for full cycle is 0. Children, okay, completed, right? Now, what is the thing? Can you differentiate and tell me the answer now? What answer you are getting? Same way, just do integration, put the limit 0 to t by 2, and this denominator also will be what? T by 2. Okay, make this process very fast. Okay, by doing practice, make this very fast so that when you get similar questions, you will be able to solve. So here you will be getting 2 I naught by pi. 2 I naught by pi. Half cycle, correct? Getting or what? Okay? Getting 2 I naught by pi. Those who are not getting, okay, leave the space there. After the class, after going home, just do this and see. Okay, I am not here to teach integration, right? I am not going to put time here. Instead of that, we will be moving to the other concepts. Other terms, if we are starting by the month of June and all, we will be doing all these peacefully. Okay, now I am rushing. Now, see children, so the answer is the average value of I for half cycle. Okay, average value of I for half cycle. Okay, this is going to be 2 I naught by pi. This average value also correct. Sometimes they can give this one also. Okay, this also means mean value or average value. Clear or what? Done? Right. So I said sine omega t or sine theta average value for full cycle will be 0. For cos also 0. So likewise I shall give you certain terms here that they are all 0. Full 0. Okay, so you need not waste your time trying to solve it. Once you see that patak, that will the average value be 0, provided if you give full cycle. Okay, so first thing, okay, number 1, sine theta, the average value. Okay, so this is applicable 0. So here I can give sine 2 theta also, average value will be 0. Okay, same way cos theta is equal to cos 2 theta, average value will be 0. Okay, suppose sine theta cos theta, sine theta cos theta, its average value also will be 0. Okay, so what you need to do is sine theta cos theta, just put a 2 here, divide by 2, make it sine 2 theta, then integrate it and see. Same process children, I request you, whatever I am giving, you should go home, you should see that. Okay, today itself, so that you will become pretty comfortable to find the RMS value. Once if you get such question, you will jump on that and finish it. Okay, so this is what. Another thing is, yeah, fourth one is sine square theta is equal to cos square theta. This is equal to 1 by 2. This is the average value of most common functions. So for positive half cycle, we can say is 2 I naught by pi. This is going to be minus 2 I naught by pi if it is negative half cycle. Okay. One more variant I shall tell you. One more variant of this half cycle is nothing but write this point. Any value over half cycle is 0. Okay, sentence mudiyala. Okay, not wrong. Any value over half cycle is 0. Kalliriyadhukku munadi sentence okay poorthi serudhu just give permission. Any value over half cycle is 0 if one quarter is positive and the other quarter is negative. Okay, you will understand. Okay, you will understand it now. See, suppose if this is the signal, one quarter is positive means positive, negative. What is the average value of this thing, this piece? 0. One is positive, other is negative. Full cycle is 0 just because half is positive, half is negative. No. So now no one will irritate us. Information is complete. Pakka. Note it down. So take that figure also so that you will understand. Okay. Now put the heading RMS value, root mean square value. Okay, RMS root mean square value. Take this definition because it is important. It is the value of DC. RMS value. Okay, it is the value of DC. Okay, it is the value of DC which produce same heat in given resistance in given time. It is the value of DC which produce same heat in given resistance in given time as is done by alternating current. When passed through the same resistance for the same time. Okay, it is the value of DC which produce same heat in given resistance in given time as is done by alternating current when passed through the same resistance for the same time. Okay, suppose if we are passing different currents and we are measuring different heat through that, then that DC will be same as the RMS value of that AC which produces the same heat. இதுக்காக தான் கஷ்டப்பட்டு RMS எல்லாம் படிச்சுட்டு இருக்கு. Now you might start liking RMS இல்லையா? இவ்வளோ நாளாக நம்ம ஏதோ ஒரு சிலபஸ் பேர்டன் மாதிரி நினச்சிட்டு இருந்தது. Now we are able to understand the physical meaning now. இவ்வளோ நல்ல ஆழ்ந்து இன்னும் இப்போ தான் we are recognizing, right? Okay, now we will see how to calculate RMS value. So RMS value is nothing but root mean square. First process is square. Okay, so suppose if okay, so suppose okay S first process is square. So sin omega t square sin square omega t. Done. This is first one. Second means what? average. So next is we need to find this. We know that. Okay, so we will do, put the limit 0 to t, then the function I naught square sine square omega t dt, this limit divided by t. Okay, just integrate it, get the answer. Okay, just do it now, come on. So this is equal to I naught square is constant, we will take it out, then integral 0 to t sine square omega t dt. This t also we will put here. Okay, now to integrate sine square omega t into 0 to t 1 minus cos 2 omega t divided by 2. Correct, no? 1 minus cos 2 omega t divided by 2 dt. Correct. Now this integrate this. Clear or what? So we will put the 2 here. So okay. So now I square by 2t. Now we will integrate this. We will be having t. Okay, t minus integrating cos 2 omega t. What we will be getting? Sine 2 omega t divided by 2 omega 0 to t. Correct or what? So actually, should we do this much? Should we integrate this term? Is it required? Average value of sine and cos will become 0 anyway. Okay, so you can verify after going home, just directly putting 0 also, you can verify after going home. Now we are giving here this full value. Okay, so this is going to be I naught square by 2t, and here putting the upper limit t, and this is going to be sine 2 omega into t divided by 2 into here, okay, 2 omega. Okay, so then the remaining things will become 0 over. Now substitute omega is equal to 2 pi by t. Substitute omega is equal to 2 pi by t. Finally, you will be getting this as I naught square by 2. I naught square by 2. Okay, so until this second step, okay, until this second step is over. Third step is what? Root. Third step is root. So we could say IRMS is equal to what? I naught by root 2. I naught by root 2. Okay. Okay, this 2 was there, that 2 we took it outside. 1 minus cos 2 omega t by 2. This 2 also, whatever possible, we'll take it outside. Otherwise, we'll have to put that also inside integration. Mistakes can come. Done? Clear? So, any value, whatever it may be, okay, any function if you get, and they are asking what is the RMS value of this. Okay, direct function means, okay, fine, I naught sin omega t or I naught cos omega t, I naught by root 2 we can do, just like that. But if it is some other function, okay, just like not directly I naught sin omega t, but I naught sin omega t plus I naught cos omega t, okay, or 3 plus 4 cos omega t, something like that, then follow this process. But while doing this, whichever average terms are 0, directly throw them out, so that fatafat you will be getting the answer. Okay, right, now do one thing. Okay, suppose I is equal to 2t square plus 3. 2t square plus 3. Find the average value of this for a time period of 3 seconds. Find the average value of the function I is equal to 2t square plus 3. Any function, if we need to find the average, what? 0 to t function divide. So I put the same function here, 3 seconds they have given, I put the limit, right? So now we can integrate this. 1 by 3 into 2t cube divided by 3 plus 3t, putting the limit 0 to 3, correct? So 1 by 3 into, so here if we multiply, this is going to be 27 divided by 3 plus 9. Yes, simplify this, this is going to be 9, right? So, correct or? So 1827 by 3, 9? Yes, 9 ampere, correct or what? Okay, so first session, okay, we'll take a small break, then we'll continue. Okay, students, so see, to find the maximum value, of something, suppose if we have some functions like a sin omega t or a sin theta, there is no confusion. Okay, suppose, say for example, I is equal to a sin theta, theta is same as omega t, so a sin omega t, then we can say I max is going to be what? A. Suppose we are getting I is equal to a sin theta plus b cos theta, like that, or same as a sin omega t plus b cos omega t, then what will be the maximum value? Any idea? Those who know can say that. Both are there, number 1, number 2, number 3. Suppose I is equal to a plus b sin theta, a plus b sin theta, okay, or I is equal to a sin square theta. In all these cases, this one we can say directly, okay, that is the maximum value. For the second,
a square plus b square.
root of
A square plus b square plus 2ab cos phi by 2.
okay, any other answer? Okay, this is just like I max is equal to root of a square plus b square. We can stop there, only that much, root of a square plus b square. Okay, right? about this one and this one? Those who know can. Here this one I max is just A, okay, just like that case. What about this one? What is this actually? This one, okay, see, this is like this, okay, this is actually AC plus DC. This A, if we draw that A separately, suppose if we draw A separately, if this is time, okay, the signal A, so this can be theta or omega t, anything. Suppose if we are drawing just A of graph, this is going to be like this. Suppose if you draw another graph plus another graph like this, that is B sin theta, okay, B sin theta is going to be like this. So when you add this, what will happen is this whole signal will go up, all signal will go up. So this A will become the carrier. This is A and this one is nothing but B sin theta. So for this signal, B is the maximum value. Since A has lifted this up, here maximum going to be A plus B. Okay, so note it down. So trigonometric expressions can be given. It will take some time. Okay, we are not using much trigonometry in AC. We will be using vectors, and that will make our chapter very easy, dead easy. If we directly do trigonometry, this is going to be very difficult. Okay, done. Now regarding phase, okay, regarding phase we have discussed phase, lead and lag. What is really a phase? That I did not tell. Okay, see, phase is position and direction of that physical quantity. Suppose if it is voltage, then direction and position means value of that physical quantity. Suppose when we write completed, right, this one, suppose if I draw like this and if I write IE is equal to I naught sine omega t. So phase means this omega t will decide. I naught means simply the amplitude. I naught means simply the amplitude, maximum value. This sine omega t will decide the instantaneous value. In this omega t. Omega t means what? Actually theta. Omega t means theta. Just give any comfortable theta, the theta which you love. 30 degree, sine 30 degree is 1 by 2, no? Okay, so you like them, right? So same way, suppose if this is already completed 2 pi here, okay, so 2 pi plus 30 or what? So if we take this, we will be getting the value of I naught. So this is going to be what? Sine 30 is 1 by 2. This is going to be I naught by 2. I naught by 2. One more information I am getting, I naught by 2 I got. One more information is whether it is this direction or whether it is this direction I will be getting. So when it comes here, things are changed and changed. Now direction is coming down, the other one direction is going up. So phase will give us direction and position. So position means actually what? Value, number 1, number 2, direction. Number 2, direction. Okay, these two details we are getting through phase. So where you have written about phase, you can add these details or if you need. Okay, so 2 ampere current minus 2 ampere. Okay, time theta whatever. What is the I average of this full cycle? I said I average or E average of cos, sine, everything will be 0. That we discussed. What about this one? ധൈര്യമാ I average of this one 0. Okay, I average of this is nothing, just this is positive and this is going to be negative. Okay, now what is the I average for half cycle? One by pi. 4 by. Okay, why is it so? I naught is 2. So 2 I naught by pi. Okay, any objection? யாருக்காவது ஒரு மனவலி? someone is worried, ஏன் இப்படி சொல்றீங்க, இது தப்பு தானே? any problem? யாருக்குமே எந்த கவலையும் இல்லையோ? you might have, you will not agree this, no? Preeta? Agree? Not agree, okay. So what is the problem here? This we have derived for what signal? Sinusoidal signal. He is from Nepal. He is from Uganda. This is square wave, that is sinusoidal wave. So இது இங்க போட்டா இது இந்த ஆப்ஷன் எங்க இருக்கும்? அங்க இருக்கும், சிரிச்சிட்டு இருக்கும். Come, I am here. நம்ம முடிச்ச உடனே நமக்கு ஒரு நிம்மதி. Okay, நிம்மதி மட்டும் தான் வராது. So the average value of cycle is nothing but one simple half cycle na throughout it is 2 ampere. So 2 ampere over constant தானே, அதுக்கு ஏதாச்சும் ஆவரேஜ் இருக்குதா? எல்லாமே சேம் 2 ampere. Okay, done. So I square full cycle average value of I cycle answer Mukesh? 300 என்ன? 0 ஸ்டிவாக்குக்கும் செட்ரிக்குக்கும் நடுவில் உட்காந்துட்டு இருக்குல்ல. வாட்ஸ் யூர் நேம்? அஸ்லாம். யூ ஆர் அஸ்லம். அஸ்லம் என்ன? நல்லா சொன்ன எனக்கு புரியாது. எனி ஆன்சர்? லாஸ்ட் சான்ஸ். வாட்? 0 தானே? 0 தானே? அடுத்த கொஸ்டினுக்கு போகலாம். சரி, ஸோ அவ்வளோதான். ஓகே, நெக்ஸ்ட் டாபிக். பாசிட்டிவ் நெகட்டிவ் இருக்குல்ல, கேன்சல் ஆகாதா? இல்லை, அது தப்பு தான். ஆன்சரும் சொல்ல மாட்டேங்கிறது. 0ன்னு போட்டால் யூ டோன்ட் எக்ரி ஆல்சோ. So see this 2 ஆம் சொல்லிக்கோங்க. நீ அமைதியாக உட்கார வேண்டாம், நீங்கள் பெரிய ஆள்னு நிரூபிக்கலாம். Tell. 4. This the squaring, differentiation, integration is not only for equation. Equations are diagrams are equations. Correct or what? Equation of straight line is there, diagram is also there. So we can add them, we can subtract them, we can integrate them, we can differentiate them. So when we square, what will happen? Okay, so what will happen when we square this 2 will become 4. 2 will become 4. So this will become 4. 2 4. Okay, this is minus 2 square பண்ணும்போது என்ன? minus 4 தானே? என்ன ஆகும்? 4. So this will go for it. So 4. Okay, so square பண்ணும்போது when we take average, the negative term will vanish. So that is why we are taking RMS also. Okay, so inga தப்பு பண்ணலாம், no issues. Intentionally making you doing mistakes just because, so that it will be good. Right, fine. Now clear? Any doubt? Give you some details about measuring devices. So we have this hot wire ammeter, hot wire voltmeter, and a DC ammeter, DC voltmeter. So how they work, I will ask you, we will discuss. Suppose DC meter, ammeter as well as voltmeter. Okay, what is the instrument we are using for that? Instrument for DC. Okay, say suppose if this is DC, this is AC. Instrument. Actually, what instrument we are using? Moving coil galvanometer. Moving coil galvanometer we are using. This is what we are converting into ammeter and voltmeter. Correct. Here we are using hot wire instrument. So hot instrument we will be using, that is used for measuring voltage as well as current. The technical details of that we don't have to study. Okay, so simply hot instrument we can write. Right. Next point is, what is the principle of this? Moving coil galvanometer works on what principle? யார் சொன்னாங்க? ராஷரீரி மாதிரி இருந்துச்சு. You said. Okay. Yes. So it's nothing. Moving current, magnetic effect of current. That is the principle. Simply what you said. Correct. Okay. Magnetic effect of current. Okay, what about hot wire instrument? Hot wire instrument, heating effect of current. Heating effect of current. heating effect of current. Clear? Heating effect of current. Okay, so because of heating effect of current, that is the reason we were so specific about I square RMS. Okay, right. Now, what this one reads, what one will read? I mean, the question is, this one, see, we are saying we are studying AC. So if we pass an AC current or AC voltage, what this one will measure, what this one will measure, that is the question. Okay, it's AC. Here what will, here that average value. Okay, so this is going to be average value. So that is the reason this reads 0. Okay, what about this one? IRMS or VRMS. Okay, so that is the thing. They will read differently. Okay. Okay, now deflection. Here we can say deflection is proportional. Deflection is proportional to what? Magnet we cannot change, no. If we keep a magnet there, then till the world ends, this will measure based on that magnetic field only. For voltmeter as well as for ammeter, moving coil. So when this question is asked, your thought should go not current electricity, but in the last session you might read that radial field and all we were thinking, sin theta was there, threw it out, then we made it only phi, then who are all were there? Current or what? The deflection depends. How much is entering, that much torque will vary. Less current, less. Okay, this is coil is like this. I is equal to 1 ampere, deflection is this much, came back. I is equal to 2 ampere, oh, 2 ampere, deflection is more, then came back. 3 ampere more, likewise. Correct or what? Because of I, the torque was more. Correct or what? Right. Now what about here, this one? Okay, this is nothing but deflection is proportional to heat. Deflection proportional to heat. Okay. Okay. Now one more thing is, in this case, 1 ampere, 2 ampere, 3 ampere, likewise it will measure. Number of deflections will be like 1, 2, 3, 4, likewise. In this case, what should come? What will come here? Heat. Joules, that is unit. But what will be the measurement of current will come? I square. I square will come. So 1, 4, 9. Likewise it goes. Because we are depending on heat. Okay, so mark that also. Okay, so this is number of divisions we can say. Scale. Okay, scale. Okay, square of 1, 4, 9, 16 likewise. Okay, now take down certain points. So once if you know these points, then the questions will be nothing. You feel like these questions are very easy because twisting question only, but if you understand them, things will be easy. Okay, take down first point. If the frequency of AC is F, shall I erase this? Completed. If the frequency of AC is F, then it becomes 0 2f times in 1 second. if the frequency of AC is F, if the frequency of it becomes 0, 2f times in 1 second. Okay, say for example, let us say 3, frequency is 3. Frequency is 3 means how many waves I should draw? 1, 2, 3. Okay, so 1 here, 2 here, 3 here. Okay, now starting from here, what asking is how many number of times the signal becomes 0. So just see, this is 1, 2, 3, 4, 5, 6. So already starting from here, you need not consider this. Statement is, if frequency of AC is F, then it becomes 0 2f times in 1 second. Frequency means what? The overall time taken for this, all these 3 segments is what? T is equal to what? 1 second, which is nothing but time period. That is what is called frequency. Okay, so that will become 0 2f times. Okay, next point. Direction of current changes. Direction of current changes 2f in 1 second. Direction of current changes 2f times in 1 second. Okay, just see same example. Okay, now this is one direction, no? This is one direction, so here it is changing the direction. So this is number 1. After reaching here, this is again changing, number 2, then number 3, then number 4, then number 5, then number 6. Okay, clear? Okay, so direction of current changes 2f times in 1 second. Okay, maximum 2f times in 1 second. Values will become maximum 2f times in 1 second. Okay, values will become maximum 2f times in 1 second. So number 1, number 2, number 3, number 4, number 5, number 6. Clear or what? So states they will ask as questions. If you know this, matter of 2 seconds, mark it and go. Okay, so now certain points also I will give you as a summary, then after that we will go to circuit theory. Circuit theory is easy. Correct, shall I erase this? Okay, so suppose a sinusoidal waveform. Sinusoidal waveform just like this. Okay, so in this case the average value, okay, RMS value I will write RMS value, and this is going to be average value. So in this case RMS value we know I naught by root 2. So 1 by root 2, it is better to know that value also. So 0.707. okay, so this is what is the RMS value of sinusoidal waveform. So what about this one? 2 I naught by pi, correct? No, 2 I naught by pi, bracket you can write half. For full it is 0, we know that already. So this is nothing but 0.637 I naught. Remember this if possible. Okay, Suppose half wave rectifier. Along with this, I am just discussing this. This is going to be there in semiconductor. Okay, they are in semiconductors, but semiconductors you will be discussing the we are discussing here. Along with this, if you study, this is going to be easy. So half wave rectifier means, okay, this will be, this half wave rectifier means it will allow only positive things, only positive parts. Negative parts will be truncated. So in this part it is going to be vacant, only this will come. Okay, so for half wave rectifier, RMS value is going to be I naught by clear, and this is going to be I naught by pi 0.318 I naught. Okay, for full wave rectifier, okay, positive sides they will allow, negative sides they will flip and send as positive side. Okay, so this is how it is going to come for full wave rectifier. Clear or what? So in this case, this is going to be I naught by root 2 0.707 I naught. This is the this is the RMS value of full wave rectifier. Average value will come as 2 I naught by pi. Okay, 2 I naught by pi. So its value is going to be 0.637. So what is the average value of full wave rectifier, even for full as well as for half? It will not become 0. This average value will be 2 I naught by pi itself. Okay, so you can understand that this is full and half. Okay, for both of them it is going to be same. Suppose if I write here square and rectangular, square, what will be the average RMS value? Square and rectangular, sorry, square, just say square, square, rectangular, both are same. In this case, square or rectangular, what will be the average value? Square as well as rectangular. What about average value? For full cycle we have seen 0. For half cycle it is going to be how much? The maximum value only, right? This is going to be like this. This is how I naught or minus I naught. There is no I naught, actually constant. So we can say simply it is going to be I naught, and RMS value is also going to be same. If we take a square and if we take a root, same value will come. One more thing I will give, sawtooth. Okay, sawtooth. Just like this. Okay, sawtooth. So here the RMS value is going to be I naught by root 3. I naught by root 3, and this is going to be I naught by 2 for half. How much is this area? That much will come here also. Okay, so in that sense this is going to be negative, this is going to be positive. So for full cycle, again average value is going to be 0. So that is why I naught by 2, that is also for half. Okay, clear? Now we have discussed about phase. Okay, now we will discuss about phasor concept. Once if you understand phasor, then we will get into circuit theory. phases. Phases. Regarding this, we have studied phase difference also. You know either phase lead or phase lag. Okay, suppose if V is equal to V naught sine omega t plus phi, I is equal to I naught sine omega t plus phi 2. So what is the phase of I with respect to V? Is nothing but phi 1 minus phi 2. The phase difference between I and V is nothing but the difference of this part, this one and this one. Correct? Omega t is same, so directly we can take phi 1 minus phi 2. That is the phase difference. Now phasor concept is nothing but we will be considering current and voltage as vectors. We will apply algebra for solving all these problems. Direct method is trigonometry. Sin omega t, cos omega t, sin into cos omega t, all these things, bulk, average, RMS, everything. It will take lot of time and it is very difficult also. If we do, things will go wrong. Fortunately, if we consider current and voltage as vectors, then if we solve, we are getting the same result. That is how we will be getting shortcuts now. You yourself might have made, if you do, then why to worry all this. So like this is an official shortcut, okay, or accepted shortcut worldwide. Okay, so this is the method. So what we are going to do is we will consider current and voltage. They are not vectors, but if we consider them as vectors, whatever answer we are getting using trigonometry, same thing. Okay, so what we have started, we will implement phasor concept and we will do the problems. That is the introduction of this. Clear? Now you can phasor. So phasors are, say, anti-clockwise rotating vectors. Phasors are anti-clockwise rotating phasors. Okay, one point is length of the phasor. Phasor is nothing but anti-clockwise rotating vectors. Okay, say for example, if this is a waveform, how much is this length? That much will be the length of the phasor. Okay, suppose if this is voltage, this is V naught, then this length will be how much? V naught. Now suppose if the instantaneous value is this. Okay, suppose if we are considering the instantaneous value of this, then if we take here the same line, this we will rotate in anti-clockwise direction. So this will be the position. Now suppose if the value of V is instantaneous, if it is going to be V naught, what will happen? This will come to this position V naught. Now suppose if it is here, what will happen? Same line will come here. So this will rotate. Once if it is here, then this phasor will be here. So it will be rotating. So what we do, instantaneous value is this much, we will take a vector like this. What is the value of current? Suppose if this is voltage, rotating like this, same way we can take for current also. So now this is V naught sine omega t. This is V naught sine omega t. So this phasor which we are discussing is voltage. Now I used to take another color, but I do not know in camera this will understand. Red color. Okay, red color. suppose if current is there, okay, and current is equal to I naught sine omega t, so can I write I naught is equal to E naught by R sine omega t? Correct. Okay, I is equal to I naught sine omega t, I is equal to E naught by R sine omega t. Suppose if E naught is 10 and resistance is equal to 5, then I naught will be what? 2 ampere. So I could write 2 sine omega t, right? So if we compare, E is equal to 10 sine omega t and I is equal to 2 sine omega t. Now if I, correct, no? Everything is right. Now if I draw the same waveform of I, this will become what? This will be like this. This thing can be what? 2. This thing can be minus 2. So both current and both are in same phase or different phase? According to the phase definition, what you can say? Same phase or different phase? Okay, you might saying different phase just because of considering the value. Okay, considering the value. That magnitude we need not consider here. Just you can understand that if it is here and if this thing is here, they are in same phase. Okay, this is that understand. Same value, same position, same number means it should be here, no, need not be. Okay, in this circular motion or in this motion, if it is here, both are in same phase. Only thing is amplitude or magnitude of displacement is different. Okay, understood? So they are in same phase. So I can write, if this black color, if this is of voltage, okay, voltage, they are all voltage, then I can say that this is nothing but current. Clear? Understood? Okay, so you want to take some running notes, please take it. Now I will show you how the phase difference in phases. If you have any doubt, you can ask.
Initial version തുടങ്ങിയിട്ട് again initial version വരുമ്പോൾ ഒരു complete cycle എന്ന് പറയാം.
ഇവിടെ വന്നിട്ട് ഇവിടെ വന്നാൽ ആയി, ഇവിടെ വരണമെന്നില്ല, ഇവിടെ ഇതും ഇനീഷ്യൽ പൊസിഷൻ ആണല്ലോ, അങ്ങനെയല്ല, ഇതൊരു ഷേപ്പ്, ഇതൊരു ഷേപ്പ്, ഇതൊരു ഷേപ്പാണ് അല്ലേ, ഇത് ഇങ്ങനെ ഫുള്ള്, അടുത്തത് ഇങ്ങനെ വരും, ഇത് ഇവിടെ ഒന്നും സിഗ്നൽ ഉണ്ടാവില്ല. ഇതിൻ്റെ അർത്ഥം എന്താണെന്ന് വെച്ച് കഴിഞ്ഞാൽ ഒരേ തന്നെ പല വാല്യൂ വരും, അവിടെയൊക്കെ ഡോട്ടാണ് ശരിക്കും. When we draw like this, actually there will not be signals here. Okay, just in the course we will be drawing like that, but if we assume that here signals are there, the meaning is like at the same time different values of current and voltage. Correct? No, same time different values of current and voltage. That is not possible. That is now possible with quantum physics. Quantum physics, these kind of discussions will come. Gauss, Tippett and all will get some significance in quantum physics. Okay, no one knows that completely, but in generally we cannot take like that. Current and voltage are not phase, right? Okay, so understand that here no signal. Clear or what? Now suppose if current and voltage, if they have a phase difference, so say for example V is equal to V naught sine omega t and current I is equal to I naught sine omega t plus pi by 2. If they have a phase difference, then how we will do this? So okay, so this is voltage. If this is voltage, then what about current? Current is leading. Current is leading. So current will start from here. Already this might have started somewhere here. Okay, suppose this is pi by 2. This the same here. This is going to be minus pi by 2. Ahead of phase by pi by 2 means it will start from here, or in the same way, before this becomes maximum, by pi by 2 radians difference, the current will be maximum. So this will be like this, correct or what? And that is how. Okay, likewise. Okay, remaining I am not drawing, just understand that here. Suppose if I need to draw its phasor, whenever voltage is here, the current will be leading by pi by 2. Current will be leading by pi by 2. Just looking at this, just understanding this, we can say I is equal to I naught sine omega t plus pi by 2. This is going to be V naught sine omega t. So likewise we can play. Okay, this is enough. Okay, just for understanding of phasor, this is enough. Remaining all the things just like vectors we will do. Okay, not even vectors, very simple vector also. Okay, we vector aanne puriyadu and alavukku simple. Done. So initial phase difference is phi. If voltage is V naught sine omega t, is it hot inside? This is not working. AC Joshua, the adachirno. Okay, so suppose if voltage is V naught sine omega t and I is equal to I naught sine omega t plus phi, then what will happen? Okay, this is going to be voltage. Okay, V is equal to V naught sine omega t. I is equal to I naught sine omega t plus phi. This phi is initial phase difference, means initially itself, okay, right from the beginning, I is different from voltage. Based on this is positive or negative, this can be lead or lag. So we could say that if this is a phasor diagram, this will be I, which is leading the current with leading the current by phi. Okay, this is how we can write. Now based on the instantaneous value, this phasor will rotate. We can say this is leading because this phasor rotates in which direction? Anti-clockwise direction. Okay, so when inductor comes, when capacitance comes, which one will lead, which one will lag, all these things we will be able to see from this. Clear? Right. Now we will one handout is ready. We will solve the problems from that. Till then we will continue circuit theory also. Okay, so once if we finish circuit theory, it will be easy.